Okay, I'm going to show you how I make this not take up an entire piece of paper. There are some ways that you can kind of cut down on the amount of work. The first step is how many solutions? Look at the degree, 3. So I write a big 3, and then I put a plus and a minus next to it. I know there's 3 solutions total, and then I'm going to write how many positive and how many negative. The positive solutions come from the sign changes. So this term is positive. This term is negative. We changed to negative. This term is positive. We changed to positive. This term is positive. We stayed positive. There are 2 sign changes. The one funky thing about Descartes' rule of signs is that it's 2 or less by 2, so it's going to be 2 or 0. If there are 2 positive solutions, how many negative solutions would there be? 1. All right, so I now know that there are going to be 1 negative solution and maybe 2 positive solutions, but maybe 0 positive solutions. So should we test the positive numbers or should we test the negative numbers? I'm going to test the negatives because I'm guaranteed, I know there has to be 1 solution that's negative. There might be 0 solutions that are positive, so we'd have to test all of those numbers and not get the answer. I'm going to test the guaranteed. The possible solutions come from the last number, from that 20. How can we multiply to get 20? We got 1 times 20, and I space them out so I can write them in order. We've got 2 times 10. 4 times 5. I made too much space, but that's okay. Now we're talking about positive or negative 1, positive or negative 2. So there's actually 12 suspects here. There's 12 numbers that could potentially be solutions. 3 of them are going to be the solutions. We have to find the 3 that work out of the 12. You could say, oh, I'm going to start with 10. Don't start with the big numbers. Start with the smallest number, work your way up. We test using synthetic division. 1x cubed, negative 8x squared, 11x, and 20. The coefficients, the numbers in front of our polynomial, are the numbers that go in the synthetic division. We're going to test the negatives, so I'm testing negative 1 first. Negative 1 times 1 is negative 1. That gives me negative 9. That would be positive 9, which is positive 20. This is looking good. Did we really get 0 on the first try? This means negative 1 is a solution. So in our factored form, we've got 0 equals x plus 1 if negative 1 is the solution, then in the polynomial it has to be x plus 1. Remember what we did yesterday? It's the opposite of what your solutions are. Okay? And then the trinomial, whatever's left, comes from the synthetic division. So we've got x squared minus 9x plus 20. Your last step is to finish factoring and solving. This fundamental theorem of algebra and Descartes' rule of signs and synthetic division, that helps us to get that first factor out that we couldn't get before. Now we know how to factor this trinomial. We're looking for 2 numbers that multiply to give us 20 and add up to negative 9. Your possibilities are already written right above. I believe that's negative 4 and negative 5. So x minus 4, x minus 5. We've got our x plus 1 from before. So our solutions are negative 1, which we found in the synthetic division, positive 4, and positive 5. Keep this in mind. If we had tested positive numbers first, we would have tried positive 1. It wouldn't have worked. Positive 2, it would not have worked. Positive 4, that's where it finally would have worked. So by testing the negatives, we actually did get our solution quicker this time. Sometimes that works in your favor, sometimes it doesn't. All right, how do you feel now? Do you feel a little bit better after seeing it a second time and seeing that it really only took up that much space, not a whole page? Let's try number 3. Okay, first of all, how many possible solutions? 3. How many positive solutions? 1. The sign changes. So this term is positive, this term is negative, so we change to negative. We stay negative, this term's positive, that's a change. So we were positive, change to negative, stay negative, change to positive. There's 2 sign changes. Does that kind of make sense? The 3 comes from the degree. And then this comes from the number of sign changes. Okay. If there are 2 positive solutions, that means there's 1 negative solution. So I am going to test my negatives because I know that there's a negative solution. Possible solutions come from this constant number 24. What are numbers that we can multiply to get 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. Whew, that's a lot. Okay, we decided to test the negatives, so I'm going to do some synthetic division here. 1, -5, -2, 24. I'm going to start by testing -1. -24 and -4 is not going to give me 0. So that one doesn't work. So then I try again. Doesn't really matter where we try again. This time I'll try -2. Yay! Our goal is to get a remainder of 0. That last number in the synthetic division needs to be 0. If it's not 0, scratch it off, try again. Okay, -2 is a solution. So if the problem is asking what are the solutions, you could right now put -2 in your answer. But now we need to find the other 2. So we've got 0 equals x plus 2. Because if -2 is a solution, that means that there was an x plus 2 in the polynomial. And the 1, -7, and 12 is going to give us our trinomial. X squared minus 7x plus 12. That's really tight right there. And then I'll factor that. I believe that's -3 and -4. So x plus 2 gives us the solution of -2. X minus 3 gives us a solution of +3. X minus 4 gives us a solution of +4.